We're super excited to actually talk about this new rating system that Velodyne proposes as a new industry standard. But I wanted to fit it within a broader topic, which is our portfolio of sensor solutions, as well as the general opportunities for the standardization of their features and validation. With that in mind, the topics that we'll be focusing on, I'd like to give you a brief introduction to Velodyne. You may not have been here during our press conference this morning. We will talk briefly about the gaps identified in the ADAS sensor taxonomy testing and validation. And then we'll focus truly on the new ADAS feature rating system that we developed. And also we'll give you the opportunity for Q&A at the very end. If you weren't here in the morning for the press conference, Velodyne is actually a worldwide represented company with facilities in Asia, in Europe, and certainly headquartered in the Bay Area in San Jose. We also have an advanced research center also in the Bay Area in Alameda. Those are our facilities around the world, about 500 employees worldwide, and certainly expanding our footprint in terms of manufacturing. So that's really exciting news, and it's based on the traction that we are getting with all the sensing solutions that we are proposing, both for the autonomous vehicle technology as well as for the ADAS technology. In addition to the automotive market space, we are very strongly represented in all these other industrial areas. We are in the new mobility space. Certainly the AV technology is part of that. We are in delivery robots, in commercial vehicles, trucks, in mapping. Mapping certainly is one of the areas that benefits enormously from the Lidar capability. In drone and unmanned aerial vehicles, in security applications. There are a couple of examples around us here. In industrial application, robotizations and automation, and also in smart city applications. We're working with various customers on stationary applications for automating the city environment, making it safer, and certainly improving traffic and the convenience of moving away in the city. Since our presentation is truly focused on ADAS, I wanted to emphasize a little bit the footprint that we have in terms of customers and partners that are relevant both to the AV space as well as to the ADAS space. So we are represented, as I mentioned before, in Asia, in North America, and EMEA, and in Europe. And this is just a snapshot of, again, our friends and partners that help us develop solutions for this market. The relevance of our presence in autonomous vehicles is extremely important because not only that we developed very good ADAS solutions for the level 2 and 3, and I'm talking about the SAE level standardization, but we learned a lot from everything what we've done in level 4 and 5 on autonomous vehicle applications. And the functions that you are familiar, hopefully, with in ADAS are actually executed at the best level in AV, level 4 and 5. So you'll see in our rating system that there are a lot of lessons learned from the autonomous vehicle technology that we are applying in ADAS, in advanced driver assist systems. What I'm showing here is the portfolio of products, which is kind of similar with what you see in front of you. But the emphasis will be on the sensor on the right side, which is the Velodyne sensor, the second from the right. The Velodyne is, along with the Velobit that we just launched today, they are the ADAS sensors that sparked a lot of interest in the marketplace, and we're promoting them as extremely good solutions, again, not only for the level 2, 3, but up to level 4 or 5 in terms of the capability of a specific feature. So the Velodyne is the first 200-meter capable sensor in terms of range. It's a very small and compact form factor, which makes it suitable for the automotive applications. And certainly with the VeloBit, we move to the next level in terms of embeddability and addressing all the styling requirements of our automotive customers. There are many other features of the sensor that are listed here. And we did develop a couple of solutions where the sensor is embedded at the windscreen location for ADAS functionality. And we have 3 vehicle demonstrators that you can actually experience here at CES. So if you are interested, please sign up and we can give you a demonstration in one of our demo vehicles. It's important also to understand that we are covering all the automotive requirements. Those are spanning over product-related requirements, literally hardware, up to functional safety requirements, as you can see, ASIL-B level, and a lot of other software solutions that allow us to mitigate interference and, again, address situations like blockage and self-diagnosis by the sensor. The topic of our discussion today is maybe also consumer-focused. And we're starting now with the basics. When you go and purchase a vehicle, you're essentially asking for the maximum safety embedded in the vehicle's capability. But what is that? And the reality is that neither the dealerships and in some cases the OEMs and others are able to properly explain what the vehicle can do for you in terms of safety. So these organizations, which are the AAA, Consumer Reports, J.D. Power, and the National Safety Council, they came together and they identified significant gaps in terms of how these features are explained to the end user, to the consumer. So the things that those 4 organizations did identify, and we are fully aligned with that approach. In the first place, they noticed that the consumers are faced with as many as 20 different names for one single ADAS feature. When I'm talking about an ADAS feature, I'm referring to something like lane keep assist or AEB, automated emergency braking, adaptive cruise control. So these are the things that I'm referring to. Unfortunately, for each of them, there is a different name by the manufacturer, so that creates certainly a level of confusion in the marketplace that we are trying to address and mitigate. The second thing that those 4 organizations noticed is that 93% of the new vehicles are equipped with ADAS. So even the lower level vehicles, you're thinking trim levels that are usually or were usually not staffed with technology. Right now, they are becoming even more technology laden, and that requires explanation to the consumer. So if you're buying a base level sedan vehicle, you will have AEB. What is the capability of the automated emergency braking in that vehicle? That has to be explained to you, and unfortunately, there is little capability, as I said, both in terms of standardizing the explanation as well as in the dealership capability to convey that message to you. So we're trying to bridge that. And ultimately, another thing that has been noticed is that 40% of the consumers that are purchasing those vehicles, they believe the car is able to drive itself. So if you buy a Tesla vehicle, unfortunately, that's the example that's being used there. Because the terminology that has been used, autopilot, that implies that the car drives itself. And 40% of the consumers that have been tested, they truly believe that's the reality. So again, a misperception based maybe also on a marketing strategy that was misleading. And the 4 organizations that I mentioned before are addressing that with terms that are much more conducive for consumer and layman understanding, if you want. You don't have to be a specialist in sensing technology or in ADAS technology to understand those things. Our efforts are along the same lines. Another organization that tries to standardize and commonize taxonomy and in general this set of activities is SAE, which is the Society of Automotive Engineering. And SAE has defined the taxonomy in this standard, which is J3016. That is for engineers. So the first topic that we are talking about is how do you explain to consumers. The second topic is how do you standardize when you talk to an engineering community. And that pertains both to the OEM as well as the tier 1 manufacturers. So despite all these efforts that have been put in place over the last years, this is still a very new industry. So taking that into account, the novelty, if you want, of all these technologies, the gaps in terms of how to test in a standardized manner, how to communicate in this environment, in this ecosystem, what are the terms that you are using, those problems have not been addressed entirely. Specifically for LiDAR technology, because we're talking LiDAR here. So if you're talking about a 250-meter range, what is the target reflectivity that can be detected by that sensor? What is the size of the target? So there are many other questions that have to be addressed in a consistent manner such that you can compare technology to technology. So at Velodyne, we did address both the consumer-related topics as well as the technical topics, again, everything that targets the engineering community, with a paper that is also endorsed by SAE. And the paper is actually speaking about exactly this particular topic of the ADAS rating system. We have a booth next to the shuttle bus there, which also allows a little bit of an interactive experience of the rating system. So again, just to recap, what are the reasons for developing this paper and what are the reasons for trying to address these questions? We talked already about the introduction of ADAS features in new vehicles, but again, there were a lot of open topics in terms of the validation and testing of those sensor technologies, and also the Encap, which is the new car assessment program, which is a kind of evaluation of a new car program from the safety perspective. Encap is also endorsing the sensor fusion approach for safety through ADAS technologies. So there is a need for actually explaining to the end user what is a sensor suite on the vehicle that would give you maximum safety. So the method that we used for this was fairly simple. We started with the main functions of ADAS, and those are terms that hopefully you are familiar with. We're talking about the automatic emergency braking and steering. We coupled them together because there are very many similarities. Lane keep assistance, adaptive cruise control, blind spot monitoring. And for each of those features, we identified the key elements. You'll see this in the coming slides. And the grading system, if you want, or the rating system, is starting with 1 diamond for minimum performance, 3 diamond for current state of the art, and 5 diamond for the equivalent of that function in an SAE level 4 automated driving. So again, just to be clear, we're rating these features here, A, B, LKA, ACC, BSM. We are not rating the vehicle equipped with this technology, because you can have, on the same vehicle, you can have a very capable AEB system, but the ACC system is more limited in terms of capability. So this is the end result and the product of our work. Starting with the first functions, automating emergency braking and automated emergency steering. If you look on the columns that we put, or the first column that we put here, those are the vehicle system performance criteria. So certainly it's very important to understand at what speed the AEB or AES will become active and effective, actually. It's very important to understand the detection reliability of that system in the vehicle. What type of obstacles can be detected? The vulnerable road users, which are the bicyclists, motorcyclists, and pedestrians, the VRUs are very important, and that's the focus of the industry currently. So that's one specific characteristic. Can the system detect and classify? Can the system detect stationary objects? What's the peripheric vision of the system? That's another very interesting characteristic. Does the system have dynamic driving intervention capability? So in other words, in addition to the passive aspects of those systems, are they able to promptly react and in conjunction with the actuators to actually do something about what they detect or classify? And then the last one is light and weather performance. So if you're looking at how we rated those two functions, if you start with the maximum speed, let's pick, for instance, 50 miles an hour, the third column. So 50 miles an hour is a pretty representative speed both for city driving conditions as well as highway driving. So a 3-diamond, you would think from the speed perspective is well suited. The range detection capability and classification is certainly mid-range because the sensor has to actually convey the information to the rest of the system and the actuators have to react. So at that speed, which is a relatively low speed, I think there is a lot of capability to perform those functions, and for the compute stack on the vehicle and for the actuators to react, I think there is sufficient time at 50 miles an hour. Does the system have near range detection? I mean, that's again very important. That's the item lower down in the columns. Does the system have limited perception coverage? All these are the criteria that actually define or drive the diamond rating. So this was the first example. If we're moving to the next example, which is the lane keep assistance, we took the same approach, but the criteria for lane keep assistance are different. So lane positioning, lane line dependence. When I'm talking about line, I'm referring to the lines on the side of the road or the middle lines that are very important both in terms of how well they are defined as well as their color and reflectivity. The detection range of that line, dynamic driving intervention capability, roadway functionality, and then again weather performance and light. Those are very important criteria. So in order to achieve a 3-diamond rating with this function, you would have to be in the middle column where you have, from the lane positioning perspective, excellent centering and occasional driver interventions only. As you know, the driver interventions are a very important metric of the vehicle and certainly of the system capability. So you're trying to minimize the number of interventions by the driver, and if you can potentially have 0 interventions, that's the ideal system. That's why I was mentioning earlier that our aspiration is to link this rating system not only to ADAS, but also to the level 4 and 5 autonomous driving. So going down the column, so mid-range detection certainly is important. With a 3-diamond rating, you would have excellent active assistance, good response to peripheral activity, lane change assist, and so on. The next function that we rated was the adaptive cruise control, and that's based on the criteria on the left side. So with the adaptive cruise control, it's not only the safety aspect, it's also the comfort and convenience. So in other words, the actuation and the response of the system has to be very smooth, and the driver cannot be going from a high speed to a low speed to a large deceleration, because certainly that would not be very comfortable. So with that in mind, the criteria for rating this system are certainly the programmed following distance capability. So if you program, let's say, 30 feet between you and the vehicle in front, certainly that capability is very critical. It has to be able to automatically resume after slow or start and stop driving in a kind of traffic jam situation. Roadway functionality, stationary object detection, similarly to the functions before, and then peripheral object detection and light and weather performance. I'm not going to talk too much about this because, again, there are similarities to what we discussed before. And I hope you get the idea on our general principle in rating those functions. I will spend a minute, though, on the blind spot monitoring because that's important both from the sensor technology perspective and also from the set of criteria because those are relatively different criteria. So the peripheral field of view is extremely important for the blind spot monitoring. And as you can see, for a 3-diamond, which is kind of the starting point for a competitive solution, you need a wider peripheral field of view. We do have the Velodyne, which is a great product for that purpose, which is an 180 by 180 and has a lot of merits in terms of blind spot detection. The other criteria are the peripheral vehicle detection and classification coverage. So when you do blind spot detection, it's probably useful not only to have the very wide field of view that I mentioned, 180 by 180, but perhaps use also the Vela software that we are developing in order to be able to classify the object which is in the blind spot. The rest is pretty self-explanatory, so again, I'll move to the end result of what we're proposing here. I'll start with what we have on the left side, which is the classic government safety ratings, the star-based safety system rating. And that, in case of crashes, for instance, is able to differentiate between various vehicles in case of a frontal crash, side crash, and rollover. So that label, you can find it on your vehicle sticker in dealerships with that kind of explanation. So what we thought is when you buy a vehicle and you're interested in the ADAS features and you'd like to actually understand ADAS capability of that vehicle, we developed this proposal for a label that would consist of the averages from all the criteria that I mentioned before for each function. So for the lane keep assist, at 2.6, it's kind of average based on all the criteria that I discussed before. It doesn't tell you exactly how the lane keep assist will do under those operating conditions, but at least it gives you a good indication of, again, how that feature is rated in the vehicle. The same for AEB, the same for automatic emergency steering, the same for adaptive cruise control and blind spot monitoring. So we certainly can enhance the label to include more functions, but that's kind of the basic proposal. This is not the end of our effort for sure, because the label again addresses one aspect, which is the consumer or the communication toward the consumer in terms of the vehicle capability on the ADAS functionality. But we're planning to do a little bit more than that. So one thing that we're trying to do is also to refine the language again, because there are descriptors like flat and straight for a road versus hilly and curvy. And again, this is very subjective, so we're trying to take out that subjectivity and make our rating system as, if you want, data-driven and as objective as possible. We also would like to include some sensor component considerations in this. And when I'm talking about the sensor component, I'm essentially talking about the placement, the configuration of the sensor suite, and the coverage. So if you look at the two images on the right side, you see with a suite of Velarays and Velobits and Velodomes, maybe, you can achieve this type of coverage around the vehicle. And certainly that would deserve a diamond rating in the 4 or 5 range. We also, as I mentioned at the very beginning, are big advocates of standardizing the testing protocols because when you go and advertise a product, you have to use a common language in order to be able to compare to other technologies in the marketplace. And that's missing right now, and that's one area of focus for us. And we will continue through various methods and events that we are organizing to educate the public. We had a very nice event last year in October, and it becomes a tradition. It's our World Safety Summit with about 500 participants from the industry and academia and regulatory organizations. So that's something that we plan to continue to do. When it comes to the very specific recommendation of the hardware for a sensor suite, certainly we can speak very knowledgeably about how a LiDAR system would look like for these functions. So what we did here is, starting with the 5-diamond rating system that we talked about before, we broke it down into those 3 categories: the LKA, ABACC on one line, and blind spot monitoring. And we're showing what would be the product suitable for achieving the respective rating. If I'm picking the 3-diamond rating again, for the first 3 functions, we would recommend a minimum of a Veloray, a 32-line Veloray, and a combination of Velobits around the vehicle. For the blind spot monitoring, certainly the Velodyne, as I mentioned before, is a very, very desirable product. And the complete LiDAR package would consist of the combination of the above. So that's the general approach, again, from the LiDAR perspective. In many cases, we did include also the pre-existing camera-based or radar-based or ultrasound-based sensing capability of the vehicle. So this is in addition to that, because again, the criteria that we put around all this diamond rating are pretty stringent. So that's why you see the kind of enhanced sensor suite requirements. I'll conclude my presentation with some other future considerations which are more technical in nature. They are related to the current limitations of the specialized tests. And we chose here to talk about a specific Encap test. And it's going to jump at you. The first limitation of the test, and probably the most important one, is the lighting conditions. So there are many other issues that we perceive with those tests, but the fact that the tests have to be performed in daylight, and in some cases even the specific lumen lighting condition is recommended, that's certainly favoring certain type of sensing technologies. The LiDAR technology is contributing tremendously to the safety aspects of those ADAS features because we can see in dark as well. And with the Encap test formulation that you see here, that's taken away. So certainly we would like to promote tests that are representative of real-life conditions rather than being more lab-focused and development-focused. So that's one summary here. What you see here is also that the distances to the vehicle, in addition to the lighting conditions, other, if you want test characteristics or parameters, like for instance the speed conditions are very limiting and very little representative of a real-life condition. And that's emphasized even more in the summary that I have here. This is the Encap test for the automated emergency braking vulnerable road users. As I said before, the bicyclists, motorcyclists, and pedestrians are in this category. And again, it jumps at you the fact that testing of the bicycles have to be done only in daylight for some reason. Pedestrian testing is done with street light condition with an illumination of greater than 16 lux, which is a lot. And the vehicle velocity is 30 to 60 kilometers an hour, so which again is a very representative city driving condition, but not so representative for a wider variety of operating conditions. So that's the message, that we are working also on this side of the equation, not only on the consumer side. We're going very deep into the technical requirements of the sensor suite, and the ADAS diamond rating feature will probably contribute to these aspects as well. So that's my summary, and looking forward to your questions. Thank you very much.